Hey everyone, welcome. In this video, I'll be rebuilding my PC from the ground up. Full custom water cooling, no hardware, no software setups. I'm sorry. We won't be going over the software setup side of things. You know, after installing Windows and all driver support for your graphics card, we won't be going to that. Just purely the hardware. The power supply is already installed to preserve my cable management. The hardest part about this is honestly going in and fixing your cables, but that's more of a a custom thing. So like a lot of custom stuff I won't really be explaining, because it can vary from person to person, but everything else is going to be from scratch. So let's get started. So I have the items here, but first we're going to start with the tools. This is an electric screwdriver. You start it through here. It has its different drill bits, but we'll only be using 2 or 3. So we have, this is just for an extender if you need harder to reach areas. We have our Phillips head we'll be using. And then we have our star. It's hard to see in the camera. It's a star, but it's gonna be a replacement for Allen keys. It's much easier to use this than go hand in hand with Allen keys. For small stuff, we'll be using this tiny screwdriver. Alright. And then these are the 3 different Allen keys. So this one's for the reservoir, Allen ports. These are for the radiators, Allen keys. Again, most of the stuff we're just using the star stuff. And these are for the really, really small ones. So let's get started. Let me explain each part. So here we have the CPU right here. This is the underbelly. You see each one there's no pins in this one compared to another one. I have another one, let me show you. Here we have, it's a different generation of sockets. So this one has pins to it, and it's really hard to see, but they come out from the bottom. This was my old CPU, the 3950X, released in 2017 for a hefty price. This one is the 9800X3D. Again, you can see there's no pins on this one. The pins are actually on the motherboard instead of the actual CPU. So this came into about $470, I think I paid for this. The CPU. So what the CPU does is, it's the brain of the computer. It handles most of the calculations, game logic, and background tasks. So if, let's say you're running a game, the game will be running primarily off the GPU to handle graphics, but this is handling all your background tasks. So if you have different screens with Google or just many, it just holds all your applications. And this sends files to the GPU to get processed. So if you have a CPU that's too slow and you have a GPU that's too fast, this actually bottlenecks it in the sense where it won't send information quick enough to the GPU. That's enough for that. Then we have the GPU. This is actually delidded. Well, not delidded, but it has no fans on it. This is the actual chip on it, on the GPU. So whenever you hear, semiconductors and everything, is really this chip is what's doing all the processing. All of these parts and everything to deliver power. And right here, it's not shown because of these thermal pads. There's the memory chips under this as well. Normally, this will come with a fan cooler, similar to this one. This was the GTX 970 from 2014, super old card. But you have this type of cooling on base GPUs. I'm sorry. So next we have our motherboard, and whenever you're doing anything with the motherboard, you always want to have it on this cardboard here. Because if you're doing work with it, you can actually scratch the under part. You don't want to damage any of the back parts here. But here, this is where the CPU goes into. This is the socket. Usually it comes with a socket cover, but yeah, I lost that. So just flip this open. The RAM goes right here. We'll get into what the RAM is next. Then you have your NVMe SSD ports here. And for this motherboard, there's 4. This motherboard is the X670E-Plus WIFI. And your Wi-Fi is actually your Bluetooth and Wi-Fi is handled through these sticks. These would screw onto the side here. I'll show you. On these, simply screw this on. And you can bend them to however you want, whatever position you want. But if you're using Ethernet, you really don't need them unless you do want to use a Bluetooth. Let's move this to the side. Then we have our SSDs, NVMe SSDs. We have two 1 terabyte and one 2 terabyte. What a terabyte is just 1,000 gigabytes. So this one's 2,000 gigabytes. This is our main drive, and this will be our whatever other drive you want to use this for. But these were, we replaced hard drives with these. So hard drives were a mechanical disk drive. You use a little needle to read, but these are way faster. So, and they're smaller, so much more efficient. This is our RAM. So RAM, this is 64 gigabytes of DDR5. This is the newest generation of RAM, and its speed is 6,000 microtransfers per second. And each one is 32 gigabytes. You had DDR4 used to have, I believe the highest you can go up to it was 128, I think it was. Correct me if I'm wrong. So what the RAM does is it's the temporary memory for whatever you're running currently. Instead of constantly having to pull items from storage devices, which is way slower, files need to be stored in the RAM to allow quick access of said files. The more RAM, the better the multitasking, so you can open a million Google Chrome tabs if you wanted. More RAM lets your computer handle more programs, browser tabs, and background tasks at once before slowing down. Let's go back to the motherboard. So the motherboard is the main circuit that connects everything. So again, your CPU has lanes, and they communicate with the RAM. That's why that's why they're closer together to reduce the input, the delay. It sends power and data between the CPU, RAM, and GPU and other parts. So, and right here are the CPU power connectors right here. I'm trying to show you the camera. These ports right here, your CPU gets powered from. You can plug in your GPU right here, is in this slot, the PCIe lane. And what else? The SSDs get powered through the motherboard. The GPU, we'll see later that you actually need more power cables because of how power hungry they are. And it's pretty much just a hub for all components to work together. So now let's get to the cooling side of things. So this is the CPU water block. This attaches directly onto the CPU, and we'll be using thermal paste. What thermal paste is, it's a non-conductive, like almost like a paste. It literally is a paste. And what it's used for is to efficiently transfer heat from the CPU onto your cooler. The reason why you don't just put them together without thermal paste is, even though this is super smooth, it looks super smooth, feels super smooth, there's microscopic grooves that when they touch, leave air in between, and you won't get proper heat dissipation from the CPU. So that's important. This is the GPU water block. It's 3 pieces. So this is the back plate right here, and how you saw on the GPU had these little pads. This is all here just to make contact, and again, it's the same thing that thermal paste does, but instead these are permanent pads, so you don't have to keep reapplying, and you just wouldn't make a mess. You don't want to get a mess of thermal paste onto your GPU parts. Not that it would instantly break it because it's non-conductive, but it just helps to be neater, more organized. This is the front part. This is dirty here. This stuff is like just caked on. This doesn't come off. It's also where the lights light up. I'll show you later. And then this is where the water would stay in. This part here is what's touching the actual GPU parts, and the metal to transfer. It's metal to transfer heat easier. So these parts here would just go on top of each other like that. And then you have screws here to make the watertight seal, so you don't get any leakage. We have our tubing. This is what you call soft tubing. But it's literally just a hose. And so you have, this is soft tubing, like I said. Then you have also rigid tubing, which is like, it's like a plastic material that you get your say it comes in 3 feet of it. You would have to not only cut it to your measurement, just like this one, but you also have to use a heat gun to bend it at certain angles, and then it's way more complicated and way more normal. So decided to stick with soft tubing. So here we have our fans. We actually have fans already attached to the power supply in the case. Again, like I said, won't be taking out the power supply, just to keep the cable management going. And so those fans are part of that whole mess behind the case. So these fans are these just come apart easy like this. Modular, sorry, that's the word. And you just put them back together like that. Put these out here. And then here we have our radiators, and this is where the water goes into. So you have it's a little dirty. The water pump, which we'll get into later, which is attached to the reservoir in the case, pumps the water through the loop. So you'll have the tubing. It'll go fit like this. Screw it in, and it goes from here into this hole. It goes around. What the little fins and everything do is it absorbs that heat and dissipates it with the fans blowing on top, and then that same water gets pushed up and around. We'll see. Alright, so one thing we have here. Dad, what was this called again? And what does it do?
GPU bracket.
Is the GPU bracket?
The GPU vertically in the case.
And then what is this part here? Why is this PCIe?
That's a PCI extension cable.
Extension cable? Alright. I appreciate it. Thank you. So yeah, pretty much what this does is, because we're water cooled, the GPU normally would sit like this. Let me show you. Would normally sit like this. If you had it air cooled, it actually show right here. It would sit like this. What we want it to sit like this in the case. That's so we have extra space for the tubes to fit through, and that's what we need this bracket for, to vertically mount the GPU. Alright, so let's get into it. This is our thermal paste right here. Had to make this, can't use too much on either part because you gotta use it on the GPU and CPU. So first, normally if you have a brand new motherboard, it would have the little CPU cover right here. That you don't need to touch. What you want to do is you want to lower this arm right here, this mounting arm. Lift up the bracket. Okay. First thing we want to do is install the CPU. So very important to avoid damage. Very, very important. So according to Linus Tech Tips, each CPU has a golden arrow that lines up with an arrow on the CPU socket on the motherboard. We want to find those and line up, because if not, we can damage both the CPU and motherboard, which we really don't want. So again, open the bracket. This is the retention arm. we're gonna simply just make sure there's no dust in there. Grab the CPU. You just want to gently avoid touching the bottom. Gently drop it in. Now, let me show you actually. This is the golden arrow right here, and on the bracket, it's very hard to see, but there's a little triangle that's there to line it up. Then you also have these little teeth here that lines up with the socket. Just drop it in. Then you want to wiggle it around, make sure there's not too much movement. A little bit of wiggle is fine. Lower down the socket cover, and then now, if you're your first time using AM5, which is the type of socket, you need a lot of force for this, which was something that got me nervous in my first installation. But as long as you do it gently, just apply the force you need, and that's it. That's all it is. Next, we can install the RAM. 2.6 of RAM again goes here. Now, on this motherboard, we need to use the A2 and B2 sockets, which is the second and fourth from the CPU right here. So we're gonna line up. Again, it doesn't matter which one of your sticks you put in. It really doesn't matter. You want to line. You have these holding arms right here. Make sure it's open. To do that, you just push them down like that. Get your RAM, your stick of RAM. Make sure it lines up. Make sure this part here, this little opening right here, lines up with the opening on the motherboard. And right there. Once you hear those two clicks, you know you got it good. Avoid using one hand, right? Like I was using one hand. I'm trying to avoid that because if you put too much pressure on one side, it just slips and it cracks and no more motherboard. There. 2 clicks. RAM is now installed. So next, what we need to do is install the NVMe. Well, we still have space. We'll use a screwdriver. This is our main drive, our 2 terabyte drive. This is where Windows and everything is running off of, and most of the games are installed here. Hopefully, it's not too blurry. So this is where we slot. This is where we put in the golden part, the teeth right here. So for these, you want to do it at an angle. Just goes in gently. Then with this, you push down, and this little hole here lines up with that screw. And you just move. Some parts have this little plastic here, simply side or some parts you have to screw in. So that's installed. Then, so when you first get your motherboard, a lot of these NVMe drive spots will have some type of thermal pad like this with a film over it that you have to peel off. Make sure you peel off. If not, your NVMe drive won't get cooled properly, and it could cause damage. So right here, you want to do it very gently. You don't want to put too much pressure on this. Just once you feel resistance, you just start screwing. Right there. Alright. Now for the second one, which would go right here. Let me show you. Yeah. Right here. So there's another one right here, another NVMe. At an angle. Push it down. We have to unscrew that actually first. Alright. Push down. Get the screw again. Alright, good. Alright. This whole thing right here holds 2. So just unscrew these. The third and final drive. This has like similar type of plastic film I was describing earlier. Just take this off. And this one we will put into our third slot. This has the same plastic retention, which is actually really good. I'll just unscrew and screw everything. And then here we have our thermal pads again. Last part for our motherboard prep will be the CPU block. This right here. So make sure I lined it up. So go like that into the case, and then this is just for the lights, for the water block. Yeah, so the proper orientation. So next, we'll apply our thermal paste. I'm gonna have to. The left hand will work. Alright, so for here we have multiple ways we can place it. We can place this in an X or a dot. We think we should definitely have enough, so we can do, could be a little generous on this one. Put a dot in the middle. Actually, might have been too much, but it should be good. And so that, when looks like it won't cover the whole thing, this should definitely cover. When you place the block, it'll push the thermal paste out and we'll get an even spread. You don't have to move it too much. Now let's get our retention screws. So motherboard prep is complete. We can put it in the case. We have all our cables here. These are the CPU cables right here. It's another one for lights. The main motherboard connection right here. This is the 24 pin. These are USB 3.0 drives right here. And these are SATA drives for SSDs, which are in the back. But that's not that important, so we don't have to get into that. So here we can do is take our motherboard. You don't have to worry about too much about this stuff breaking. As long as you're not overly aggressive with it, you'll be fine. So we gotta plug in our cables. USB 3.0 goes into this. This one is the 24 pin. Plug it in. These are the CPU cables up here. These cables can be a little tricky. Motherboard can have different locations on these cables. Just because it's all in one spot doesn't mean you can plug them anywhere. You would have to read your motherboard manual for that. Actually went in the wrong order. You should always screw in your motherboard first. So the motherboard screws go into these little slots here, little holes. Do not over tighten them. You can damage your motherboard. again, so what the GPU does is this is what you're using for rendering. So rendering 3D projects. Bless you.
Thanks.
Editing videos, which is what we're gonna use to edit this video. Video games, or even just to give yourself display out to your screen, you need a GPU. Or if your CPU has integrated graphics, which is a whole different thing, where your CPU has its own tiny graphics processing chip. Oh, actually, one important thing we forgot to do: thermal paste.
Wait, so you put it?
On the CPU. So again, here we can use the rest of this. Isn't very much left.
Only $50.
This was from the Titan. We grabbed it.
You gotta spread it.
Spread it out to the corners. This is the rectangle shape. You can't, so the corners are actually don't have any. Perfect. We had a little bit left to get the corners. Let's give it a slight little push. And we're good on that front. So now we want to put this part of the cooler on. Make sure it lines up. Those are good. So we get our screws. So this watertight seal here is very important not to mess up, because, well, then the computer is dead. So I need to go hand tighten, because I don't want to fully tighten with the tool, because it is very easy to over tighten and damage something that's on there securely. Now we need to put the back plate to finish this part of this step. The top part is just held on by the thermal pads and thermal paste, which provides some type of a suction force, but it will fall off. So we gotta align and screw the underbelly. Forgot another very important step. Now that we have the front part of the water block installed, we can now move to the back part. And there we have it. The GPU is now fully put together. So now let's install the radiators. Okay, so again, all these screws went under the bottom of the case. This holds the radiator in from the bottom. So we'll have to do the same thing on the top. Let's install the fans here first. So next up will be the radiator on the top. We're going to do the exact same process. So next, let's install the bracket. First one I want to do is this part here. This part here is just to hold the GPU. We'll screw it onto the top here. First, we need to slide it right next to the motherboard. And be careful not to scratch or damage the motherboard itself. Next, we'll just grab a couple screws. So now that we have the bracket installed, we can put the GPU in. So make sure to plug this into the PCIe slot. Clip. So I can show you. That holds in this part of the PCIe in. You need to make sure you actually plug in the PCIe extender. So according to Jay's 2 cents, most motherboards have a retention clip like this. This needs to be pushed back before the plug can go into it. If you ever try and take out the GPU, or in this case the extender, without removing this, you can and will damage the opening. Just wait till you hear a click. Well, not a click, but alright. So now the retention bracket is in. If I were to push this back, it releases this part. If I want to replug it, just push. And there's the click. So now, grab our GPU. So earlier when I was explaining that you need a GPU to have video output, this is what I'm talking about. So here you have 3 display port slots and 2 HDMI. They're just different types of connections. DisplayPort is the more desirable one if you're going for higher frame rates, and it just has more bandwidth. So let's go to installing it. So similar to the motherboard, we have a retention bracket here. This is just another PCIe slot. And here's the connection on the GPU. And be very careful, very gentle, because if this breaks, no more GPU, dead GPU. Now that the GPU is installed, we need to finish just this little part. Goes on top of the water block. This is so we can connect our tubings. So this just goes, screws here. Just secure these on. Again, this is another important thing. Make sure these screws are fastened securely. We do not want any water leaks. So now we can go to putting in our fittings. So next what we'll do is we'll have each fitting and we'll screw it into each part. So now that the fittings are done, we just need to put in paper towels, tissues, and put the coolant in, and then we're done. So the reason why you put tissues in is if there's any leaks it'll catch it before any component gets touched. Because as soon as water hits, it could short out the whole system. Now normally they have a connector that will connect to your power supply and to your water pump, so you can turn the water pump on and check for leaks without having the system running, having electricity running through it, which is just safer. But I don't have that, so it's in here, especially around the motherboard. Really want to put it wherever the fittings are, at every tube connection. On this side over here, it's not really that important. We have this is no major electronics over here. It's mainly this side over here. I'll put in a couple more paper towels. And we should be ready to pour our coolant. I believe I didn't explain this, but right here we have the reservoir here, and this is the water pump. And this is our valve right here. So if we ever need a drain, you just turn this little handle right here, and we're good. We'll be pouring the coolant in from right here. Now using our big Allen key. So now this is not just regular water. It's not supposed to put any regular water, because then you can grow bacteria and algae inside. So this is a special solution. It's antibacterial. That bottle's done. We'll have enough of this completely to fill everything, so then we can add a little bit of water. As long as your ratio of this to water is fine, that'll be alright. So now we're good to add the rest of our coolant. complete build. We do have some air pockets here, but that's okay. You can fix that later. But this is the complete build. No leaks. The water is running. It's booting. It has a green light. I'm good to go. Thanks everybody for watching. This is my first time making any type of video like this. So, you know, just bear with me. Appreciate it. Everybody have a good day. All right.